Hello all. Today today's talk is on UWB technology in wireless sensor network. I am Kusuma MS, Assistant Professor in the Department of Electronics and Communication Engineering, Government SKSDT Technological Institute, Bengaluru. So in wireless sensor network it consists of the number of sensor nodes, each are connected to each other. So the each sensor node consists of the many smaller circuits, and this wireless sensor network present day will be having many applications such as data acquisition network and data distribution network. We have the wireless sensor network such as vehicle monitoring system, animal monitoring, wireless sensors and ship monitoring, and then management in the computer networks. So medical monitoring also is useful, and data distribution is also there in among these applications. That is, in sensor network, data acquisition from these different systems and providing the solution with the help of the data distribution network is also possible. So these sensor nodes in the sensor network, they are very active and power consumption is also more. So our current challenge is to develop the low power, low cost wireless sensor nodes with longer operation range for the multi-user environment. It is there. So in this, so all these wireless sensor node RF receiver are will be present. That is, radio frequency receivers will be there. In present condition, so UWB RF receiver architecture is very useful, which will be operating in the range of 3.1 to 10.6 gigahertz of frequency, ultra wideband frequency range. In this uh, RF receiver architecture that consists of both transmitter and receiver part. At the receiver end, we have the circuit of low noise amplifier, correlator, that is mixer with the inner signal, PGA circuit, comparator, synchronous, and then this analog part data is going to the digital baseband operation circuitry. At the transmitter end, output buffer and the bus generators are present. This is the main block. RF receiver architecture consists of the transmitter and receiver of the circuit. And next, why this UWB is required? The main regulations for the UWB are, that is, it consists of the very large spectrum operating in the 3.1 to 10.6 gigahertz of frequency. Unlicensed version is available, that is, it coexists with the other technologies also. And then power limits there, that is, peak power will be 0 dBm per 50 megahertz is possible, and mean power is minus 41.3 dBm per megahertz. This is the UWB architecture, that is with respect to the other frequency of signal. That is, UWB is very flat and is covering with the very large spectrum of operation. That UWB signals consist of the spikes or data is present with a train of short duration of a very nanosecond pulses with a low duty cycle is possible. There are two types of the UWB signals, OFDM UWB and DSCDMA UWB is possible. So the main features of UWB technology is it covering range is about 30 meters, data rate is about 1 Gbps data rate, operating frequency again 3 is divided into three parts, 1 gigahertz, 3 to 5 gigahertz and 6 to 10 gigahertz. Total 3.1 to 10.6 gigahertz is present. And IEEE standard is following for this frequency range is 892.15.48 range, and physical layers is main part is multiband OFDM and discrete DSUWB parts are there, and modulation types which are used in this UWB technology are bandpass, OOK, PAM and OPM modulation schemes are very useful. And advantages of UWB, which are the main advantages of ultra wideband technologies are, because of its low power consumption and good noise immunity. This technology is very much immune to the noise, and signal can penetrate through the walls of the materials or the was high immunity to multipath fading, and then potentially very high data rates are present. And next is disadvantages. Of course, for any system we have the advantages and the disadvantages. The higher cost, the disadvantages are mainly include the high cost, slower adoption rate, low signal acquisition time. FCC, Federal Communication Commission, has limited the emission requirement, that is power emission requirements, which should be less than 0.5 milliwatt. Maximum power will be of for 7 gigahertz of band. The UWB technology has issue of coexistence and interference with the other radio baseband technologies. Of course, both UWB or any system will be having advantages and disadvantages, but we have to take for advantages of each technology and UWB technology here for the particular applications of the wireless sensor network. Thank you.